Hi everyone, welcome to a new video. Today we'll talk about nucleophilic acyl substitution of ester. We will talk about acid catalyzed hydrolysis of ester, and we'll then talk about base catalyzed hydrolysis of ester. So let's first start with acid catalyzed. So acid catalyzed hydrolysis of ester occurs when you react it with H2O, a weak nucleophile. Thus, you need an acid to protonate the oxygen of the carbonyl group to then increase the strength of this electrophile here, the carbon of the carbonyl group. So how this happens? We have the lone pairs on the oxygen grabbing one of the protons here, creating a resonance here, in which we have a positive formal charge on this carbon, which makes it much more electrophile and ready to be attacked by a nucleophile. In this case, water. So water is going to attack this carbon, forming this tetrahedral intermediate, now what we want to do is deprotonate this water to then give this oxygen here its neutral charge. So for this to happen, we will use a base. In this case, we'll use water. That will deprotonate and have this bond here rolled back on the oxygen, giving, I'll start from under, bring this one is neutral charge and OH. And now we have H3O plus leave here. Now we have two possible leaving group in OH and OCH3. They are both as equal in basicity, so we would protonate here this CH3O, or this oxygen, so he can leave as methanol. For this to happen, we will use an acid. So here I like to do, right here we got H3O plus that was protonated, so water came out of it, and then we use this water to deprotonate. I got an acid, and now we reuse the acid to protonate and make this here a better leaving group. So we have CH3, H plus H. Now here, this is ready to leave. And I forgot. H2O. Now this is ready to leave, leaving us with this here. One last step. So we end up with our carboxylic acid, is to deprotonate here, so this bond can roll down and reform the carbonyl group. For this to occur, we will use the base here, or water, to go and deprotonate, and then this one's going to roll down, forming our carboxylic acid. And then H2O plus. So one thing that really helped me to understand and really see what to do from this beginning is, well, first you can see that here in Ester needs to be protonated, because this is, first off, not a good leaving group, and this carbon here isn't a strong electrophile, because there is a resonance occurring here between those two oxygen and this carbon, making this carbon here more stable, thus not a strong electrophile. So for this reason, we need to protonate here the oxygen of the carbonyl group, creating this resonance structure here, and then this positive charge having one of the resonance intermediate, having a positive charge on the carbon, making it a stronger electrophile. Thus we can then start the process of the nucleophilic acyl substitution. And then one thing I really like to do is to write my H2O plus and then have the H2O leaving. Now I know that the next step, using this base, I will deprotonate, and then I have an acid coming out of here, and then the next step will be to protonate, and here the same stuff. All right, so I hope this was helpful for the acid catalyzed hydrolysis of an ester. Now let's go with base catalyzed. The base catalyzed hydrolysis of an ester is super simple, because even though this ester is in resonance and this is not a strong electrophile, a base is a strong nucleophile because of this negative charge. So it doesn't need no protonation, so it can attack the carbon right away, making this go up, giving us this tetrahedral intermediate, and now after that, this is ready to leave. This goes down, giving us this product. But we are not done here. For the base catalyzed hydrolysis of an ester, we will end up with a product with a carboxylate anion. Here in this case, this base is going to do an acid-base reaction with the hydrogen of this carboxylic acid, giving us the final product, which is a carboxylic carboxylate and methanol. So this was the base catalyzed and this was the acid catalyzed, and I hope this was helpful. Thank you for watching, and feel free to ask any questions in the comment. Thank you.